Hey everybody, welcome back to the series. We had discussed adding another customer at the end of the last video. So at the last video we had successful connectivity from site A to site B and vice versa for customer Cisco through the MPLS cloud. So this time we're going to just to kind of show or demonstrate the versatility of the MPLS cloud and the fact that it can serve multiple customers with overlapping subnets. We're going to go ahead and configure the infamous Acme. So I swear, man, Acme is like the most popular name in lab training videos, you name it, out there. So what better way to pay homage to Acme than to put it in this video as well. So I modified the topology, just dressed it up a little bit. We added Acme Site A over here. Let me go ahead and start the boxes. So we've got Acme Site A with just a single router and Acme Site B with a single router, just to kind of make the demonstration more focused on the MPLS side and the overall connectivity. I decided we don't need switches. What we'll do is we'll just introduce 4 loopback interfaces on the router to kind of simulate a switch that sits behind the router. And we'll just advertise those into BGP, and we'll verify end-to-end connectivity with sourcing our pings from the various loopbacks. So let's jump right in. Let's start with Acme R1. We will need the service provider R1 and service provider R3. We'll have to get on both of those boxes as well, because what we'll end up having to do is the VRF configuration and the route targets, and then do the exchange thereof. So we'll just need those two, and we'll need, like I said, both Acme routers as well. So you can see these are brand new. I haven't really thought about IPs too much as far as WAN connectivity. We should be able to just use the same ones, to be honest, because they're going to be in different VRFs as far as the service provider goes. So we can probably just do that. So let's give it a host name real quick. I might not talk as much. I'll just probably cruise through this just to kind of get it on there. I'd like to get all this done in one video just to kind of demonstrate things. So I think we used 192.168. Can't remember if it was 0 or 1. It was 1, and then 2. Okay, yeah, that's right. So we did 1.1 for the customer side. We'll no shut him, and then we'll go right into router BGP. I chose 65,001 this time, just to change it up. Neighbor 192.168. 1 dot. This should be, sorry. Darn it. I just looked at it too. The service provider is 1.1. We should be 1.2. Okay, let's go back to router BGP. Neighbor 192.168 1.1. Remote AS 7029. And then we'll go ahead and activate him. By activating him, by the way, it also allows you to use the advertised routes and received routes, which is kind of nice. It's nice to be able to verify that. And then we'll go ahead and we'll say, I think we'll probably do a redistribute connected here. So let's go ahead and do the loopbacks first. I'm going to do the loopbacks really quick. So interface loopback 0, IP address is going to be 10.1.0.1. We'll give it a /24 so it kind of simulates a network. Interface loopback 1, 10.1.1.1. interface loopback 2, 10, 1, 2, 1, and then interface loopback 3. Okay, so we've got everything's up. We've got the WAN connectivity, and we've got the 4 kind of makeshift networks. So let's do this. Yeah, we'll just redistribute connected. That's fine. So we'll go into router BGP 65001. Go under the address family. Redistribute connected. Okay, we'll keep this simple. Okay, let's hop over to service provider router 1. So we'll need to do the VRF. So if we kind of cheat and look at the VRF for Cisco, we're basically going to kind of mock this up, right? So we're going to say, sorry, up here, this one. So we're going to say VRF definition. We're going to say ACME. We'll make the route distinguisher 65001. This is going to site 1 or A, I should say, so we'll make it :1. And then we'll do route target 65001 : 1, right? So do show run section VRF. So we've got 2 VRFs now, newly created ACME and the existing Cisco. In fact, let's go ahead. We're going to need to do this anyway. So my plan was to make the route target 65001 : 2, same as what we did with Cisco on this one. So we'll go ahead and just put the import in for the 2. So that's there. So that way we don't have to come back. We know it's already there. Right? So, okay, so that looks good. Let's go under the interface. One thing I will demonstrate here too, just because I think it's worthwhile to mention. I'm going to go in E02. And before I put it in the VRF, I'm going to slap the IP address on it. I want to show you something. So IP address 192.168, what do we say? 1.1/30, right? So you can see the router didn't yell at me for using the same exact IP address as I used here, because this one's in VRF Cisco. So for all intents and purposes, the router thinks that nobody's using this IP address because it's in a totally different routing table. But what I want to show you is you put the IP address on there, right? But what if I add the VRF now? So if I do VRF forwarding for ACME, look what it does here. Interface has been disabled and the address has been removed due to enabling the VRF ACME. So if I do show run interface E02, it literally just took the IP address off that I just assigned, and it shut the, well, I think it was already shut, but either way, it does that automatically. So if you did not have a copy or you didn't know what that IP was, you could burn yourself, okay? So it's a well-known thing that they drilled into my head when I was learning this stuff many, many years ago, so I'm just kind of passing it along, but it's still a thing as far as I know. So we've put it in the VRF. Let's just go ahead and put the IP address right back on. We will, oh, I did it again, didn't I? Do show run section VRF. Yeah, I missed it again. You believe that? Jeez. There you go. Interface E02. Do show run interface E02. Okay. Let's try this one more time. Alright, perfect. Description, we'll just say 1 gig MPLS to customer ACME. Fine. Show IP interface brief. Okay, good. So it looks crazy, right? Like when you look at it from the router's perspective, it almost looks like you're breaking the rules, right? But the only way that this is possible is if they're in 2 different VRFs, which is obviously the case, right? So far so good. Show run section BGP. So we're going to make the BGP config a little bit longer. So we're going to come into BGP. We're going to create a new IPv4 address family for VRF Acme. We will do the same network statement, right? So we as the service provider are going to do our customer a favor, and we're going to advertise the /30 connection that we're providing them. So we're just basically doing them a favor. We're going to cut and paste this, but it'll be 65,001, and then we'll go ahead and we'll activate and do the override as well. Okay, so a lot of copy and paste because we're reusing all the IPs and stuff. But you can see, I know I flew by it, but we got a BGP message saying that the neighbor for Acme is up. So that's a great sign. So there's the full BGP configuration, right? So the only thing we've added in this case is here. So let's check the routing table for VRF Acme. And wouldn't you know, we've got all 4 loopbacks that we've advertised from the Acme site. Okay, so this is looking wonderful. So let's go over to, I'll drag this on this side, and let's configure Acme site B router 1. So interface, we'll define our loopbacks. It doesn't really matter what order we go. 10, 2, 0, 1. You don't have to no shut loopbacks. It's just a habit that I always do no shut, but you don't have to. So just so you guys know. Loopback 1, 10, 2, 1, 1. Interface loopback 2, 10, 2, 2, 1. Interface loopback 3, 10, 2, 3, 1. Okay, so do show IP interface brief. We've got our 4 loopbacks ready to go. That looks good. Let's go ahead and do E00. Description 1 gig MPLS. We will give it IP address 192.168.2.2, right? We will no shut him. Then we will go into BGP 65001, and we'll say neighbor 192.168.2.1. He's in remote AS 7029, and we'll go ahead and activate him. And then we will, if we try to redistribute here, it doesn't let us. You have to go into the address family, redistribute, connect it, and we'll save him. Let's go to service provider router 3. Show run section VRF. Okay. We're going to steal that. We're going to steal that. Route target 65,001:2. Address family IPv4. And then we're going to do the route target 65,001:1. Do show run section VRF. So we've got our newly created VRF for Acme with its route distinguisher, which is different than site A. However, we did the import for A, so we should be good there, and we've activated the address family this time, which is the step I kept forgetting. So interface E02, we're going to say that's VRF forwarding for Acme. We're going to give it IP address 192.168.2.1/30. We're going to no shut that. And then for, actually we'll give it a description. We said what? We said 1 gig MPLS customer Acme. Do show interface descriptions. So 01, That was the, yeah, okay, good. Customers, yeah, fine. Did I not? Yeah, I just typed it different. It's fine. Okay, so where were we? BGP, right? View show run section BGP. Did I do that? No, I did not. So BGP, we're gonna steal the address family, but we're gonna make it Acme. We are going to advertise the same exact network. In fact, we're going to advertise the same network, peer with the same guy, right? So it's all the same, right? The only thing we didn't accommodate for is the allow AS in, or see what it did there? I'm glad I did that. We didn't accommodate for the override or the allow AS in. But what I just pasted a bad command in. So I copied the same autonomous system number for Cisco, but you see that we're configured for 65,001. So what it does is if you've got a conflict, so if you're working with a service provider and you, let's say, inadvertently give them the wrong AS number that you're participating in, and they configure it to point to the one that you said was wrong, this is what you're going to get. You're going to get bombarded with messages saying that, hey, I'm trying to peer with somebody that's not in the AS that you told me they're in, okay? So let's go ahead and fix that. So we're going to remove that. And we're going to change it to be 65,001. There's a magic local AS command that you can actually run to fake it out. So you can actually, a way around that could have been this. So if when it was yelling at me, it says that it's somewhere in here it should say it was expecting AS whatever. I thought it did. I don't see it. At any rate, if you know where the conflict is, or there's another situation with that too. So like, if you took over a network or something, and you're trying to make a new peering, or you're trying to add some other network segment onto what you've already got, you can only run one instance of BGP. Like I can't go in here. Let me do it on Acme because I don't want to necessarily mess with the. In fact, well, let me do before I show you that. Let me just turn on the AS override for Acme VRF real quick. So we'll say AS override and show run section BGP. Okay, so we've got the network, the neighbor, the activate, and the AS override. So we should be good. Let's just go over to Service Provider 1, show run section BGP. Let's just add the, oh, we did it on there. Okay, good. Okay, perfect. Oh, that's right, because we copied it. On router 1, we had it, and I copied it over. On router 3, we didn't. We did the allow AS in on that side. That's right. If you were watching and following along, you know what I'm getting at. So we did override in both cases for Acme as opposed to the demonstration that I did last time. So that's fine. Let's go to, let's verify connectivity, and then we'll play around. I'll show you what I was talking about. So let's go to Acme Service Provider 3. Let's hop on him real quick and see if he got the routes. Okay, so show IP route for VRF Acme. We've got all the routes. Okay, so as soon as I brought the peer up for site B and the import was set for the one, which was done prior to that, we're essentially getting all the routes. So this is great, right? So let's go over to Acme router B, or Acme B router 1. And let's check our routing table. So it looks to be good, right? So show IP BGP summary. We should see that the peer is up for 2 minutes and 56 seconds, and we've got 6 prefixes. Those prefixes are in the BGP table. Okay, we can see where they were learned. These are the remote routes, all right? And then we've got the local routes, which are the 32.768. So that's good. So they make their way into the routing table as expected, all right? So with any luck, if we try to ping 10.1.0.1, source it from, let's say, loopback 0, we've got full connectivity. If we trace route 10.1.0.1 and we source it from loopback 0, should have did no domain lookup. Okay. The only thing... So we're on B router 1, right? Okay, good. Yeah, cool. So we went through the, that's our service provider edge, right? So 2.1. Next hop was 10.2.3.2, which in a real world, the service provider hides these hops. There is a command that we can run to hide them, to disguise them, because it's, you could argue it's a security thing. The service provider doesn't want to advertise what their internal underlay networks are, because the customer doesn't need to know that. So like if you did a trace route on a real MPLS environment, you'd probably get asterisks or stars for some of the hops that they're hiding, and that's kind of normal to see that. But in our case, for lab purposes, I like to show it because we can see that it goes through the hop between router 2 and 3 based on the IP, and that's the label that's from router 2 and the label from router 1. So it's pretty cool to see it. We hit the edge on the other side, and then we hit the Acme Site A, router 1. So that's good. We're good. What did I want to show? What was it? Oh, the set. You can't run 2 instances of BGP, right? So show run section BGP. So if I try to type router BGP 65002, it doesn't even let me, right? It says BGP is already running, the autonomous system number is 65001. So that's where that local AS command kind of comes in. It's like a workaround to not being able to configure 2 instances of BGP. You can run the local command and still maintain what you need to maintain, which is kind of the whole point of the command. So just wanted to point that out. So hopefully this kind of reinforces the fact that, you know, you've got Cisco Site A that's running, everything's the same except the autonomous system number, right? And that could even be the same too. It doesn't matter. So Cisco's got all the same IP address schemes as Acme, okay, on both sides. There has no impact on connectivity. And just to kind of verify, right, if we go to, let's go to Cisco switch 1. So if we ping 10.2.0.1, source it from 10.1.0.11, we still have connectivity, right? There's no issue there whatsoever. So we have connectivity whether we're on the Cisco site or whether we're on the Acme site, as we've proven. So there's no overlap as far as the IPs go, all because of virtual routing and forwarding instances. So I wanted to kind of drill that home, just kind of demonstrate it, just so you know you're not just going on my word here. You've seen it live. We configured a new customer in, what's it been, 25 minutes? I don't know what the recording's at, but not hard. Once the backbone's in place, it's not that difficult to bolt on customers. So when you do turn-ups with service providers, they normally schedule an activations technician or a SAT engineer. You get on the phone with them, they have their paperwork, they say, okay, I'm going to configure my side, you configure your side, you're usually up in, you know, a matter of minutes. So that's kind of the process and what it looks like in a lab, but we're mimicking it to kind of be a little bit more realistic. So I think we're going to stop beating the customer to customer branch site connectivity up for now. We'll start to introduce some data center technologies as far as Nexus switches and some other pretty cool stuff. So the series is going to continue to grow. We're going to continue to build upon this topology, and we'll go as far as we think we can go. So I will see you next time. Most likely this topology is going to change one more time to have a data center, and we can decide if that data center is going to be for Cisco or Acme. My vote is maybe Cisco, but we'll figure that out in the next video. All right, guys, take care.